Online students, is my voice is loud and clear? Clear, right? Done. So in the last class, we are discussing about the inferential statistics and various statistical tests. And today, let us complete the inferential statistics. With this, the entire inferential statistics will be completed. And from here, we'll move on to the next topic in the next week. Now, coming to the inferential statistics, the last part of the inferential statistics. Yeah, just a minute. So within the inferential statistics, what are the statistical tests we are doing now? So while doing the statistical tests, what are the steps we have involved means? So these are the steps. What is the step one? That is nothing but steps involved in the statistical test for continuous data. First, we have done the null and alternate hypothesis, followed by we have checked the alpha in the given question, followed by we have checked whether the given data is normally distributed or not. By default, it is normally distributed. And we are going to draw the normal distribution diagram, and also we are going to write which side the rejection area we are having, and followed by we are going to select the test, and after selecting the test we are going to apply the test. Apply the test means take the formula, and within the formula we are going to substitute the value and calculate the test statistic value, and from that p value. After calculating the p value, here based on the p value, either we'll accept or reject the null hypothesis. For accepting or rejecting the null hypothesis, we are having the two options. For accepting or rejecting the null hypothesis, we are having the two options. So these are the two options. Okay, everyone, please make a note. These are the two options. To act last step, what are the based on the p value, either accept or reject the null hypothesis, we are having the two options. What are the two options means? One is directly check your p value comes under acceptance area or rejection area, and accordingly you accept, which we have done in the last class. In the yesterday we have completed this one only, and with multiple examples. Now this option, when you are going to choose the option one, when you are going to choose the option one means when you are having the questions with you, when you are having the questions which are asked in the questions without using the Jupyter. So simply to say, when you are doing manually, option 1, select option 1 when you are doing the statistical test steps with manually. When you are doing the Python code using the Python, go with the option 2. Option 2 is for when you are using the Python code and you are applying the steps involved in the statistical test using the Python code. Are you doing the statistical test manually means go with the option 1. If you are going with the Python code means go with the option 2. Is the point is clear? Everyone, right? For the option 2, what happens? What is option 2 means? If p value is less than alpha, reject. P value is greater than alpha, accept. This is option 2. If p value is less than alpha, reject the null hypothesis. If p value is greater than alpha, accept the null hypothesis. This is option 2. Okay, when you have to choose the option 2? Option 2, when you are working with the statistical test, you are doing using Python. When you are using the Python, go with the option 2. That is, p is less than alpha, reject null hypothesis. P is greater than alpha, accept null hypothesis. When you are going with the manually, what are the statistical tests you are doing manually, then how you are going to accept the null and alternate hypothesis means, that is better to go with this option. Check whether your p value comes under acceptance area or rejection area. Statistical test doing manually. Go with this. Write this one in the notes clearly, guys. This last step, that is sixth step, step number 6. Up to calculating p-value, there is no difference. After calculating the p-value, the difference comes. Is the point is clear? Don't unnecessarily confuse between the two of them. Whether you are using Python code or whether you are doing the manually. Simple. Right? Done? Now, in the last class, one more time I am repeating, 3 to 4 examples I'll show you first using the manually, just as a recap. Already we have completed in detail. Okay? Just as a recap, I will explain. And from there, we'll move on with the Python today. In the Python, last step is very easy. See the p-value. So in the Python, what happens means apply the test and test calculate. All these things will be done by the Python only. This will be done automatically by the Python. Now, so here I'm going to show you an example. Okay, what is the difference between manual calculation versus what is the difference? Yeah, guys, just give me 1 minute of time. Online students. Arjun, ఒకసారి రా స్క్రీన్ అయిపోయింది. Yeah, online students, just hold for 1 minute. Guys, earlier I told you hackathon will be conducted on Saturday, that is April 5th. Long back I have told you now. That is not tomorrow. It is extended to next Saturday. Because we have not completed the data cleaning. Actually, by this time we have to complete the data cleaning and we also have to complete the matplotlib and seaborn. But statistics we have discussed so much of detailedly, slowly. Multiple classes we have taken. For descriptive statistics only, almost we have taken 7 to 8 classes. Basically, descriptive statistics will be completed in 3 or 4 classes, but slightly we have extended for you and we have discussed more detailedly in the class. And of course, it is an advantage only for you because we are understanding the concepts more in detail. But here the point is tomorrow's hackathon was extended for the next Saturday. Tomorrow there is no hackathon. Tomorrow there is exam. Based on the entire statistics, tomorrow there is an exam. Complete statistics interview questions. It is not MCQ. It is interview based questions, where it is the theoretical questions. We are going to ask theoretical questions. You have to answer theoretically, right? Done. Okay, guys. So let's start. Now here we are having in terms of example number one. First, let us discuss manually. When we are going to do the manually means only in the certifications tests, like tomorrow. Tomorrow in the test, I may give the one question from the inferential statistics. You have to do the complete manual and you have to tell me whether to accept or reject the null hypothesis. Okay, you have to give this one whenever we conduct a test, something like this, or whenever you are going to have some entrance. For example, some entrance will be there. For example, Wipro, before conducting the interviews, they'll conduct for some entrance test. So some kind of entrance related to data science or data analytics, I mean related to data analytics, whenever you are having, in that case we are going to use the manual. Remaining cases we are not going to do manually. It will be done only by using the Python. This is point number one. Okay. Now, so whenever we are doing the manually, what happens means they are going to give us in terms of, okay, what are the Z test or anything, X mean, that is sample mean in the Z test formula. Okay, Z test formula. What are the tests you are going to apply? X bar minus mu divided by sigma by square root of n. So in the question itself, they will provide all the values. Sample mean will be provided. Mu is nothing but for which you are applying the hypothesis test. Your H naught value will be there now. H naught value will be for what value? That one only mu. Okay, in the H naught, whatever the value you are going to write. In the null hypothesis, some number you are going to write, right? That number only will be the mu value in the Z test. And X bar minus mu divided by sigma by square root of n. Remaining all the values, they will only directly give in the question. What you have to do? You have to just substitute. What you have to do is just you have to substitute these values. What are the values are there? Values in the equation, okay, or in the formula. Substitute the values in the formula. In the yesterday pizza example or milk packet example, we have done this one only. Just we have substituted the values in the formula. After substituting the values in the formula, we will get what? Output as test statistic value. This is the one which we are going to receive as the output once you substitute in the formula. After getting the test statistic value, using the test statistic value, okay, using Z table for test statistic value, what are the test statistic value you have got? Okay, you are going to calculate the p value. Using the Z table, you will calculate the p value. Outside you will get the p value. Now what are the p value you have received? You have to check whether the p value is in the acceptance area or whether it is in the rejection area, and you have to reject. Okay, is the point is clear? If it is in acceptance area, you have to accept. If it is in the rejection area, we have to reject. So your step number 4, step number 5, step number 6 will be like this. What is step 4? Select the test. What is the test you are going to select? One sample test. Okay. And what is the next you are going to do? Apply the test. What is apply the test means? Substitute the values in this and calculate the test statistic from that p-value. After calculating the p-value, from that you are going to say whether it is in the acceptance area or rejection area. If it is acceptance area, accept; rejection area, reject. This is when you are doing manually. Anyone has questions in the manual? Yesterday, whatever the problems we have solved. Like open your pizza example. First example, whatever we have done in the pizza. In the pizza example, first we have written the what is null and alternate hypothesis. In the pizza example, we have written first what is null and alternate hypothesis. After writing null and alternate hypothesis, alpha. After that, normal distribution. While writing the normal distribution, we have drawn the curve like this. And wherever the value greater than 30, we are going to reject. Now, what is the rejection area percentage? Rejection area percentage is equal to alpha. Alpha is the rejection area percentage. That is 5%, which is also 0.05. So automatically this is 0.05% area means it should be 0.95. So this is the diagram. Right? Next, when in the third step, whenever you are doing manually, you have to draw the diagram. Next, select the test. What is the test you are selecting? Miss Z test. In the Z test, apply the formula. What is the formula? X bar minus mu divided by sigma by square root of n. After applying the formula, you are going to get the test statistic value. After getting the test statistic value, calculate the p-value from the Z table. And what are the p-value you have received? This p-value comes under acceptance area or rejection area 0.681, comes under 0 to 0.95, or it comes under 0.95 to 1. Means it comes between 0 to 0.95, which is acceptance area. So that is the reason we are going to accept the null hypothesis for this case. So finally what we are going to do in the step 6, we are going to accept null hypothesis. For which one? For pizza example, we are accepting the null hypothesis. Okay, now coming to the second one. What is the second example? Milk carton. In the milk carton, you are going to write the null and alternate hypothesis like this. This is your null and alternate hypothesis. Null hypothesis is equal to 500 ml. Alternate hypothesis is not equal to 500 ml. Alpha is equal to 0.03. So rejection area is how much? 0.03. Now this 0.03 is the rejection area. Diagram is what? This is the diagram. Now 0.03 exclusively right side only 0.03 or only left side 0.03? No, it is the half. So right side you have to take 0.015. Left side you have to take 0.015. Right side half, left side half. Now this is 0 to 0.015. This is 0.985. This is 1. Right? Now apply the test. After applying the test, once you substituted, what is the value you have got? 2.74. With the 2.74, you got the 0.9969. Where is 0.9969 will comes? In the area of between this one. So it comes under this area. So it is comes under rejection area. So we are going to reject the null hypothesis. Simple. Point is clear? Manually whatever we have done. Okay, manual calculation is clear now. Now let's try with one more example. Okay, now you have to do in front, now only instantly you have to do. Okay, what is that one means? Kinley. Okay, example name is Kinley. I am giving the values given. Okay, number of samples are collected as 25. Now only you have to complete, you only have to do everything. Okay, 25 bottles are collected randomly. And population standard deviation, what are the population standard deviation? Okay, is 10 ml. Population standard deviation is 10 ml. And what are the samples? 25 samples I have corrected. For that sample mean is in terms of 900, sample mean is 995 ml. Sample mean is 995 ml. Sample mean is 995 ml. Population is 10 ml. And 25 samples are collected randomly. Check, okay, or do the hypothesis testing to check whether the bottle filling is having minimum 1000 ml or not. Check whether, apply the hypothesis test and say whether bottle has minimum of 1000 ml or not. That is the question. Okay, this is the question, guys. Minimum 1000 should be there. Now, in this case, what is the step 1? Step 1. Formulate the null and alternate hypothesis. What is the null hypothesis? Population mean is greater than or equal to 1000 ml, because my requirement is minimum 1000. More than that, anything is there also? No action. Next, alternate hypothesis is population mean is less than 1000 ml. Okay, first step completed. Anyone has any question in the first step? Only step 1. As one of the student has asked me to repeat, it will be helpful for everyone by doing this one. Is this one is clear? Now, what is step 2? Step 2. What is step 2? Alpha. In the question, alpha was given? No. Then what is done? By default, alpha is equal to 0.05. That is default. If not given, means automatically you have to take. Automatically you have to take. Now, step 3. What is the step 3? Normal distribution diagram. Draw the diagram. Sir, whether it is normal distributed or not, whenever they ask in the interview, whenever they apply the test, automatically by default it is normal distributed only. Otherwise, they have to give the data to you to check that one. Okay? When you are doing the manually, by default it is normally distributed. For manual things, by default, normal distributed. Diagram. What is the diagram, guys? Which side rejection? Left side or right side? Okay, less than 1000 ml only. Left side. How much area I have to consider? Left side? 5%. That is 0.05. Now here, what is the value I have to take? 0.05. This is 0. This is 1. So 0 to 0.05 is rejection area. 0.05 to 1 acceptance area. Done. Okay. Completed. Diagram also completed. Step 4. What is the step 4? Test. What is the test I have to select? Z test, because automatically population standard deviation was given. So one sample Z test. Okay. Okay. Next. What is the next step? Step 5. What is step 5? Apply the test. Apply the test means what? Substitute. Substitute and tell me what is the test statistic value. You are having all the values now. Test statistic, what are the values are required? X bar is there, that is 995. Mu is there, which is 1000 here. Divide by sigma is there, 10 is there. Square root of 25. N also is there. All the 4 values are available with you. Now tell me what is the value? Minus 2.5. So test statistic value by substituting in the equation, what you got? Minus 2.5. Exactly 2.5. Huh? Okay, done. Now open the Z table and tell me P value. For minus 2.5, what is the P value? 0.0062. As one of the student is saying, others, could you please confirm? In the Z table, but minus 2.50. Open the Z table. So minus 2.5. Where is minus 2.5? Here. Minus 2.5. Second digit is 0. Obviously it is 0.0062. Whatever the student has told, correct answer. Right? Now, tell me whether it comes under acceptance area or rejection area. It comes under rejection area. Now, what is the answer? Step 6. What is the answer? Finally, accept or reject? Reject the null hypothesis. Reject null hypothesis. Since it comes under rejection area, we are going to reject the null hypothesis. It comes under acceptance area, we'll accept the null hypothesis. Simple. Everyone is clear now? Just p-value comes under which area? That's it. When you are doing the manually, it comes under which area? Acceptance or rejection. That's it. Completed? So all these things, are we going to do the t-test? Yes, t-test instead of population standard deviation, sample standard deviation. Population instead of sample standard deviation, population was given, it is nothing but t-test. Here, yes. And this is called as t-test. When population standard deviation is unknown, we are going to apply the sample standard deviation. Sir, sample standard deviation also unknown. It is not unknown. How it will be unknown? Because data will be with you only now. Sample data will be with you only. You can calculate sample mean, you can calculate the sample standard deviation. Everything can be calculated on the sample. Population only cannot be calculated. Sample can be calculated. Sample data is with you only, right? So obviously you can calculate. Is the point is clear now? Same logic as it is, only formula is different. ANOVA test formula is different. Chi-square test formula is different. For Z test, what table we are using is Z table. For T test, T table. For ANOVA test, ANOVA table. ANOVA test is also called as F test. F, letter is F. F test. So F table we are having. For chi-square test, we are having the chi-square table. So 4 tables are there basically. For every test, one table is available. Is the point is clear? And in the certification or everywhere, you will get only with respect to one sample Z test only. Remaining test you will not get. Okay? Why, sir? Because remaining test will take the more time. When it is take the formula substitution, if when it takes more time, automatically the time will be more, means the number of questions in the test has to be less. Is the point is clear, guys? See, example here, 45 questions, 45 minutes. 45 questions, 45 minutes means one question how much minutes? 1 minute only, na? Now I have to ask the questions in 1 minute only, which can you solve? Can I ask 45 questions of hypothesis testing questions like this? Can you solve each one question in one minute only, everything? Is that possible manually, really? No. Then why will give this one in the 1 minute? How much time it will take to complete the hypothesis test, to do any test manually? Z test or anything, how much time it will take? If you are familiar with so much clearly, how much time it will take? Minimum to minimum 3 minutes, right? Minimum. To write that, you no need to tell me, but you have to write in a paper, at least fastly you have to write also, it will take minimum 3 minutes now. So Wherever the minimum 3 minutes time is available, that test only they will give this type of questions. For example, you are having the 5 questions and time is 5 hours. Exam time is 5 hours. Now one question time is what? 1 hour. Automatically the length of the question will be very high. While they'll give a Lilliput question here. According to the time, according to the each question, what other time was there, in that only the questions will be formulated. Is the point is clear? So when you are creating one question paper for 45 questions, which are 100 questions, assume 100 questions are there and time is 100 minutes. When you are formulating a question paper in this way, when you are creating 100 questions question paper, you have to give the enough time for others also to write the 100 questions answers, right? You will give the 100 questions, but you have given the time only to write 10 questions, means how others will write the questions? None of the person will get 100 out of 100 now. When none of the person gets 100 out of 100, it is waste of keeping the exam. No person in the world will keep like that. At least they'll get 70 na, 80 na, that is more than, no one will think like that. Question paper was designed for 100 marks, means students also has to get for 100 marks only. They will design the question paper in that way only. Right? Now the person who is having the basic common sense, he'll apply like this and he'll create. In the reality, many people are having the sense only before creating the question paper. Okay? Is the points are clear, guys? Everyone? Now coming to the Python code. With this, manual is completed. Now let us move on to the Python. Now when you are doing the Python code, here what is the last step means, simply based on the p value, if p is less than alpha, reject null hypothesis. If p is greater than alpha, accept null hypothesis. Only this one you remember. Remaining steps are everything is same. Now let's move with the Python code one by one. All the test, each and everything. Yeah, we'll discuss. Each and everything we'll discuss, guys. What is the formula for t-test? T-test is equal to x bar minus mu divided by s by square root of n. S. Instead of sigma, we have to write sample deviation. Sample standard deviation. Instead of sigma by square root of n, we have to take this portion has to be filled with the s. Clear? Now, next, let's move on to the next one. Okay. Done. So now I'm going to import the NumPy, Pandas and SkyPy. Okay. From SkyPy, I'm going to import the stats. Okay. Stats.cdf, stats.norm.cdf. Already you know SkyPy. SkyPy means scientific Python. SCI stands for scientific. Now, test question number 1. The length of 25 samples of fabric are taken at random. Fabric data. Fabric. Okay. And historic mean and standard deviation are 150 and 55, 5.5. Historic means population, not for your 25 samples. Historic means from the so many years onwards or so many days onwards, they are maintaining the mean as 150 and standard deviation as 5.5. Company manager want to test current mean. Current mean means what are the 25 samples you have selected. Na? For example, assume mine, I'm having the fabricating, I'm doing with respect to this cloth business. Okay. I'm only having the fabric data with me, fabrics. Now from like Raymond, I'm creating some kind of shut bits. And in the shut bit, I have given the 150 centimeters. This bit consists of 150 centimeters length. Okay. Now From how many years my shop is there means from last 10 years. From last 10 years, we are providing the shed bits of 150 centimeters with a standard deviation of 5.5 means plus or minus 5.5 range. Okay, from last 10 years. Now you came to my shop and you have selected 25 samples randomly. And for 25 samples, you have checked the length. 25 samples, you have checked length. And that length, whether it is equal to 150 centimeters or not, you want to check. Is the point is clear now? This is past. From so many years, I am maintaining so many years or so many days. Historic means, history means automatical past only. Na? Past is called as history. Past, that can be 1 year or 2 years, or it can be at least 1 month or 2 months. Our shop is having a very good history means what is the meaning? When we say we are having a history, means at least it has to run for 1 or 2 years, right? Minimum. Which was started 2 days back only, and if I say my shop is having a very good history means, none of the people will use generally. Okay, 2 days generally they will not use now. So history means past. So which is having the population data overall. Overall mean is 150 and 5.5 centimeters respectively. And company manager wants. Now this was done by the company manager. If it is done by the inspector, he requires minimum 150. More than that also not a problem. Customer also requires minimum 150. Or whether inspector also wants minimum 150. But whereas company manager wants exactly 150. If extra is there, it is loss for him. He wants exactly 150. Right? So company manager wants to test whether the current mean is equal to historic mean. Current mean means for 25 samples, what are the mean is there? That one. With the historic mean. Now assuming the alpha is equal to 0.05. Now, okay, mean is equal to 150. That is population mean is equal to 150. Population mean is not equal to 150. Alpha, second step, alpha is equal to 0.05. Earlier also 2 steps are same. If you do manually also same. What is the third step? Check whether the data is normally distributed. When you are doing manually, by default it is normally distributed and you are drawing the diagram. But when you are doing in the Python, you have to load the data. When the data was given, you have to load the data and you have to check for the normality. Whether the data is normally distributed or not. How to check the normality means by simply checking the, I told you different options to check the normality. What are the different options means? One of them is skewness. Simply by using the skewness or by using the histogram or KD plot or mean or median, anything. So check for the normality. Okay, checked. After checking the normality, now the data is normally distributed. Since what is this value? 0.29. Sir, skewness of 0.29, what is this called as? Basically positive skewed. Because some number. Exactly 0 is called as perfect normal distribution. Now, if the data skewness, if the skewness is from -1 to +1 also, still we consider as normal distribution only. If it is less than -1, we will consider as left skewed. Greater than +1 will be considered as right skewed. More than +1 will be considered as right skewed. Less than -1 will be considered as left skewed. Between -1 to +1, normal distribution. Including the -1, including the +1. Exactly -1 also normal only. Exactly +1 also up to that normal only. If crosses more than that, sir, why sir? Here also it is basically not normal distributed, but it is not having that much of deviation. For example, you told the 29, okay, 29 marks. Now you got 28.9. Almost same only na. 28.8. Still will consider almost same only na. 28.5. Still we'll consider that one only now. 28.1. Okay. 28. It will be round figure to 28. So it might be separated. But up to more than 28.5 or so, we'll make the round figure to 29 and we'll assume that it is very close. Similar way. Minus 1, 2 plus 1. We'll consider as round figure. If you go, it will get almost close to normal distribution. Is the point is clear? Now, so since the data is normally distributed, now draw the diagram. What is the diagram for this one? For this data, what is the diagram? Now, it is a two-tailed test. So, rejection is on two sides or one side? Two sides. So, left side how much rejection area? Right side how much? 0.05 total. So, in that half, what is half of that? 0.025, 0.025. And this is 0 to 0.25. This is 0.025 to 0.975 and 0.975 to 1. Is the point is clear, everyone? This is the diagram. Both sides you are going to take like this. Everyone is clear? And center is 0.95. Total should be 1. Bottom numbers, don't take the bottom numbers. Here, what are the numbers you have taken? The total should be 1. Okay. Now, here I'm having in terms of like this. What are the values there? Now, this one. Diagram is completed. After the diagram, what is the next step? What is the next step? Select the test. What is the test? Here, what is the test? Z test. Because population standard deviation 5.5 was given to you. So which test you have to select? Z test. Now that one only you are selecting. See, one sample Z test with two-tail rejection. Two-tail. Now after two-tail, now from stats model dot stats dot weight stats, you are going to import the Z test. Z test is available here. In this module, the Z test function is available. Now in the Z test function, you are going to give the data and you are going to give the value. What is this value? Means hypothesis testing value. For which one it has to do. And alternate is equal to two-sided. What is meant by alternate is equal to two-sided? Means two-tail rejection. Sir, if it is a left tail, then you should not write here two-sided. In that case, what you have to write? Instead of two-sided, you have to go with this one. I'm going to click on the shift tab. Okay, just 1 minute. So in the Z test, can you see here? Alternate is equal to two-sided or larger. Larger means what? Right side. Greater than symbol in the alternate hypothesis. That is right tail test. Smaller for left tail test. For left tail test, what you have to use? Smaller. For right tail test, what you have to use? Larger. For two tail test, two-sided. In the Python. Now once you write here two-sided and everything, now automatically it is going to return the two values. See, this function is going to take the output like this and it is going to return two values. What are the two values it is going to return? Test statistic value. Second value is called as p value. Now this is test statistic value. Sir, how it is calculated? Test statistic. In this we have imported, but what is the backend code? Means just it is applying like this. That is x bar minus mu divided by sigma by square root of n. Now, what is the difference between z-score versus z-test? This is z-test. Z-score is nothing but x minus mu divided by sigma. This is x bar minus mu. It is x bar. It is not x bar. It means overall data. So first internally it will calculate the overall data mean. How? You have provided the data na. For this data, it can't apply the internally mean in the backend. That mean value will be substituted here. And here 150. How you have given 150? Here you have written 150 na. Whatever you have given here, this will go to here. And this one, sigma. What is sigma means? It is going to calculate for the given data population standard deviation. DDOF is equal to 0. It will only apply automatically. DDOF is equal to 0. And n, number of records are there now. So it will only apply all the things. And finally, you are going to get the output as test statistic. Sir, can we do manually? Let's try. What is the first one? Let's give a try so that you'll also understand. So this one, x bar means what? This is the value. Dot mean. Take in the notes x bar value. What is the x bar value? 155.064 minus 150. This is the value. Divided by. So this is numerator. Your numerator is this one. Divide by. What is the value here you are having? Population standard deviation as 5.5. Let us write the 5.5. Divide by square root of 25. What is square root of 25? 5. I am writing directly like this. And what is the value you got? 4.6. Sir, same thing for this one also. Okay. Instead of 5.5, let me write clearly dot STD, that is standard deviation. Inside this, what I have to write? DDOF is equal to what? 0. Why? Population standard deviation, right? So x bar minus mu divided by sigma by square root of n. Now what is the value? 4.58. Almost same. With respect to slight deviation, internal values. Okay. So this is the formula which it is going to apply. And after applying this formula, now what is the value you are going to get, miss? This one. And this is the p value. Now, as per when you are doing the Python code, I told you what you have to do. P value is less than alpha. What you have to do? Reject the null hypothesis. So here what is your p value? 7.15. 7.15 is less than 0.05? No. So it is not 7.15, guys. It is 7.15 into 10 to the power of minus 6. Probability cannot be more than 1 now. Maximum probability only 1. How 7.15 will come? Probability value only maximum is 1. So it is 7.15 into 10 to the power of minus 6, which is 0.000007. Okay, after 6 zeros, 7 should be there. 1, 2, 3, 4, 5, 6. 6 zeros and 7. That is the meaning of this one. 7.15 into 10 to the power of 6 means this is the meaning. This value is greater than alpha or less than alpha? It is less than 0.05. Since p is less than alpha, what we have to do? Reject the null hypothesis. Same thing I have written. P is less than alpha. So reject null hypothesis. What is your null hypothesis? Mean is exactly equal to 150 centimeters. That is wrong. Mean is not equal to 150 centimeters. Check your machine. It is not exactly cutting at 150 centimeters. Now, this is the data. Can you tell me what are the sample you have collected? In this exactly 150 centimeters is there? 150 is there? Means machine is correctly cutting? Exactly it is cutting at 150? No. Means it is machine is having the problem. Machine or human, whoever is cutting, there is a problem. Now the manager is going to check that one. Now the same thing, okay, you are doing from the inspector point of view. Now what is the null and alternate hypothesis? Greater than or equal to. Okay. Now manual, you tell me. No need to do even the hypothesis test also. Just by seeing this one. Now it is having overall 150 plus, greater than 150, more than 150. Yes, most of the bits are more than 150 only. So it has to satisfy the null hypothesis, right? From the inspector point of view, let us cross check whether it satisfies from inspector point of view or not. Let us cross check. Whatever we have done with our eyes, let's cross check with the Python. Same answer it will give or different answer. So from this one, what is the null and alternate hypothesis? Greater than or equal to 150, less than 150. Less than 150. Okay, alpha is same, data is same, normality is same, z test is same, but what is the two-tailed rejection? No, it is a left tail rejection. When it is less than 150 only, we are going to reject the null hypothesis. Left tail rejection. Now here what you have to write? Smaller. Exactly, smaller. Now what is the p value got? 0.999, which is p is greater than alpha. Accept null hypothesis or reject null hypothesis. Now it is clear. So from inspector, it is more than 150. He is satisfied. Inspector is satisfied, but company manager will be loss. Point is clear now, everyone? Clear? Whatever you have seen with your eyes and you have concluded that, yes, most of the shirt bits, I mean, most of the fabric are having more than 150. What you have concluded? Same answer. According to the null hypothesis test also, it is giving the same. Sir, here you are only saying no, by seeing with my eyes, it is easily to conclude. Then why to do again Python? Array, here small data is there. In the reality, you will not get the small data, which can be done with your eyes and you conclude everything with your eyes. That one will not be done by using the Python. There will be no use. Large data only will analyze. Small data will not analyze. Example purpose, we are doing small data. Small data we are not going to use in the reality. Right? Clear now, everyone? So in this question, inspector, okay, instead of company manager, customer or some inspector, which inspector? Police inspector? No, quality inspector. Who will inspect is quality inspector. Quality inspector wants to test. Now from inspector point of view, this is the answer now. According to the inspector, we are going to accept the null hypothesis. Everything is clear? Right? Finally, what is the answer, miss? P is greater than alpha. So since P is greater than alpha, we are going to accept the null hypothesis. Accept null hypothesis, and we are going to say mean is greater than 150, continue. For us, not a problem. I'm not going to take any action. Since you are giving them more than 150, for us, not a problem. Inspector is not going to take any action. Now you try after the class, similar data set. What are this one I will upload for you now. Immediately after the class, I'll upload. Now you take some random values of your choice and give some values less than 150. You only try with some other data with less than 150. And you give to the Python. Automatically it will reject the null hypothesis and it will ask to take the action on the company people. So the inspector will take now action. Whenever it is less than 150, he will take the action. Is the point is clear? Everyone? Understood? So in the Python code, only one thing, P is greater than alpha or P is less than alpha. That's it. It comes under acceptance area, rejection area. That logic don't apply here. Simply P is greater than alpha, P is less than alpha. Simple. Is the point is clear, everyone? Yes or no? Now, coming to the second question. Now, for this question, the mean diameter of the bolt manufacturing company should be 10 mm. The bolt should be 10 mm in order to fit into a nut. Bolt size should be 10 mm. Then only it can be fit in the nut exactly. 20 samples are taken randomly from by quality inspector. 20 he has picked. He wants to conduct a test with 90% confidence. What is meant by 90% confidence means acceptance is 90%, rejection is 10%. Confidence is nothing but acceptance area. Level of significance is nothing but rejection area. Right? And he wants to check whether the mean is different from the specific value. What specific value? 10. You want to check for the 10 only now. Now, average mean should be equal to exactly 10, then no action. If it is not equal to 10, action. Okay? Alpha is equal to how much? 90% confidence. That is 0.9 is the acceptance area. 0.1 is the rejection area. Now it is a, okay? Now I'm going to load the data. After loading the data, what I have to do? What is the step 3? Check for normality. I'm going to check for the normality. What is the normality value? Miss 0. It is perfectly normally distribution. Perfect normal distributed. Now I'm applying the t-test. Where the t-test is available means from the SkyPy only. From SkyPy, what are the stats you have imported? There itself directly the t-test underscore one sample is available. One sample t-test. Now DD diameter with the value. What is the value? Miss 10. Okay. Now alternate is equal to two-sided. Why two-sided? Because here equal to not equal to. Two-sided. Now after two-sided, it will only apply internally the test. And you are going to get the test statistic value along with the p-value. And from that, this one. What is DF? In the G test, we have not got the DF now. In the Z test, you have got only test statistic value and p-value. Why here we are getting the DF? Degree of freedom. Do you remember? In the sample standard deviation, what we have to calculate? N-1. Here, how many samples are there? 20 samples. For 20 samples, N-1, what is the N-1? That is only number. N-1, basically. Do you remember the degree of freedom? DDOF. What is DDOF is equal to 0? What is the meaning? What is the DDOF is equal to 1? DDOF is nothing but divide by N-1 or N-0. N-0 will be applied for what? Population. For sample, N-1, which is nothing but Bessel correction. Okay, N is nothing but 20 minus 1, automatically 19. 50 samples are there, then what is the DF value will be? 49. Okay, now what we have to focus? DF or test statistic? No, only p value. Now p value is greater than alpha or less than alpha? Greater than alpha. Since p value is greater than alpha, we are going to continue with the null hypothesis. Accept null hypothesis or do not reject the null hypothesis. Both are same. Do not reject or simply accept. I'm going to accept the null hypothesis. P is greater than alpha. Accept the null hypothesis. No need to do any modification. Continue with your production. I'm not going to take any action. For example, now these people has created the bolts with instead of 10 mm, 11 mm, 12 mm, 13 mm, 9 mm, 8 mm. Like this, they have created the bolts. Should I take the action or not? As a quality inspector, he is going to take the action. Is the points are clear, guys? Everyone? Right? Just you have to observe only p value. Forget about remaining everything. Sir, select the test is in your hand. Here t test you have to write, a Z test you have to write, that you have to decide. Select the test only is in your hand. Apply the test, automatically it will only do. Apply the formula, it will only calculate test statistic, it will only calculate the p value. So in your simple example, step 5 will be done automatically by the Python. Step 4 you decide, step 5 will be done automatically by the Python. Calculating the test statistic, calculating the p value, it will do automatically. Internally some code is there. What is that code? Means formula. Code is nothing but formula. It will only substitute in the formula, it will only calculate everything, and it will only give the p value for you. Based on the p value, simply accept or reject. Point is simple, everyone. So you have to select the test. Your work is only to select the test. Okay. After selecting the test, once the test was selected, apply the test. Step number 5. What are that? Apply the test and calculate the p values there, right? It will do automatically. Apply the test and calculate the p value. So just you are applying the test. What are the tests you have selected? In the one sample t test with two-tail rejection. In the bracket, don't forget to write two-tail rejection, because here alternate you have to write. Alternate will be decided based on the null and alternate hypothesis symbol. So it is a two-tail rejection. Clear, guys? Everyone? This example is clear. Anyone has any questions? Now, Sapna is asking a question. I have question. What if we have 25 samples? Can we do the t-test, or if standard deviation is given? See, population standard deviation was given or not given? Population standard deviation means z-test. No population standard deviation means t-test. Is the point is clear? Population standard deviation is given or not? Right? Next. Can you explain the line of code again? Which line of code? Govardhan? This one? T-test code. Yeah, in the t-test, first you have to provide the data. See, whatever you have applied in that z-test, data, population mean value, alternate. These are the three things, na? Same. In the t-test also same. Data, population mean, and alternate. Same. Whatever you have written in the z-test, same. Govardhan. Clear? Done. Next. Here df of 2 means I have stored in the df of 2. Variable name is df of 2, column name is diameter. What are the data frame and column, so that column values will be extracted. Okay. Now come to the third one, ANOVA test. So one sample z test Python code is completed, one sample t test Python code is completed. Now let us move on to the ANOVA test. Now in the ANOVA test, okay, we are going to take like this, where we want to check whether the marketing organization outsources their back-end operations to 3 different suppliers. Okay, they have given to the 3 different suppliers. The contract are up for renewal, and CMO means Chief Marketing Officer. CMO wants to determine whether they have to renew the contracts for all the suppliers or for a particular supplier. CMO wants to renew the contract of a supplier with least transaction time. If all the contracts are in the same range, he will renew all the contracts. Now, what is the null and alternate hypothesis? No difference in the mean transaction time. Their means are same. Now, let me show you the data set so that you can get a somewhat clarity. Along with the question, please see the data set. When you are working with the Python or something, then please observe the data set. When you are doing manually, along with the question, first write the given in the notes. Then you will understand something. Don't only read the question. After reading the question, immediately write in the notes, given, whatever was given, so that you will get a complete clarity on that question. Right? Now, here, okay, this is contract renewal data set. So supplier A, supplier B, supplier C. Total how many suppliers are there? 3 suppliers. And this is the time taken for them to complete the work. This is the time. Okay, for each work, this is the time. Now, average time. What is the average time? Sir, simply calculate average time. No, sir. For this column, calculate average time. For this column, average time. For this column, average time. What average time you will get then? Sample mean you will get. What I want? Population mean is same or not. Sample mean is same or not, not is the question. Population mean is same or not is the question. So, 3 contracts are there. What is the, I'm going to give null hypothesis. Null hypothesis says that average contract time by the supplier A, average time by the supplier A, average time by the supplier B, average time by the supplier C. 3 are same. No difference in the transaction time. Now, alternate hypothesis says that there is a difference. They are not same. Averages are not same. Averages are same. Is the point is clear? Everyone? Yes or no? This is step number 1. Sir, for example, 4 columns are there. 4th column. 5 columns are there. 5th column. Add like that. Sir, 2 columns are there. Only 2. How many columns are there? That many columns. Average value of the first column is equal to average of the second column is equal to average of the third column. Like that you have to continue. Is the point is clear, guys? Now, next. So you are going to write the average supply time. What are the average supply time is there? We are going to write the average supply time. Now, next. So here alpha is equal to 0.05. Step 2 is 0.05. What is the step 3? Check for normality. Here how many columns are there, guys? 3 columns are there. So 3 of them separately, everything should be normally distributed. Sir, for example, if they are not normally distributed, then in the notes you have written that one. Open that. What are the steps involved in the what are the steps in the step 3? Check for normality. If they are not normal, convert. If they are not normal, we have to convert. Sir, out of 3, 2 of them are normal, 1 is not normal. Then whichever is not normal, that one only you convert. Remaining 2 you keep as is. Which column is not normal, that one you have to convert. How to convert? That we'll see in the next class. Okay. So today's class, what are the examples I have selected? By default, everything are normal distribution examples I have selected. In the next class, I will show you how to convert a skewed data to normal distribution data. Right? Sir, if you show in the next class, for example, if you share in meanwhile for us, what are the questions and something, how we can do, for example, if it is not normally distributed, how we can do, miss? That is the reason I'm not going to share you the task with respect to Python code. I will share you the task or questions which is manual. Manual means automatically it is normally distributed only now. So let us complete the manual questions. Tomorrow you complete the manual questions. Monday I will show you how to convert from skewed data to normal distributed data. Then I will share you these tasks related to data sets. That one also you practice them. Is the points are clear, everyone? Now check for the normality. I'm going to check for the normality for A 0.12, which is normally distributed. For B, what is the skewness value? Minus 0.06, that is also normally distributed. Sir, minus no sir, I told now minus 1 to plus 1. Next 0.25, this is also comes under minus 1 to plus 1. So this is also normally distributed. So 3 columns are normally distributed. Since 3 of them are normally distributed, what is the test we have to apply? Open in your steps involved. What is the step number 4? What is the step 4? Select the test. How to select the test? When the number of columns are more than 1, what is the test you have to select? ANOVA test, which is also called as F test. So here in this example, what is the test I have to select? Means ANOVA test. Why? Because it is more than 1 column. Now what is the step 5? Next one. What is the step 5? Apply the test and calculate the p-value. Apply the test and calculate the p-value. Now I am going to apply the test. What is the test? Means F test. F one way. That is the function name. And in that I am going to give the 3 columns. What are the 3 columns are there? 3 columns I am going to provide, and it will give the output as, what is the p-value? 0.10. Now what is the alpha? In the question alpha was given? In the question alpha was given? No. Then what is the default alpha? 0.05, which we have considered in the step 2. Automatically 0.05. Now here p-value we got as 0.10. Since 0.10 is greater than 0.05, should we accept or reject? Accept the null hypothesis. Since p-value is greater than alpha, do not reject the null hypothesis. What is the meaning of do not reject? Means accept. Accept the null hypothesis. Now what is null hypothesis? All the 3 contracts are average time is same. Now what the CMO is going to do? Renews all the contracts because all of them are in the same range. Sir, for example, they are not same range, sir. We have rejected the null hypothesis. They are not in the same range. Now 3 of them are different. Then what we have to do? Who is better? We have to check. Means again we have to take individually one by one, and we have to apply the one sample test for each of them separately. Is the point is clear, guys? Everyone? Now see here, I want the 3. I am having 3 students with me. Take simple example. 3 students are there. Who is a good student? By default says 3 of them are same. No difference. For example, 3 of them are not same. It was concluded that 3 students are not same. Then which student is best? Individual test the individual student, and from that you conclude. How you are going to test? Means for every student you give the marks are greater than or equal to 70. If first student satisfied, second student not satisfied, third student not satisfied, then what is the meaning? This one only. So for example, 70 was satisfied by A and B, then increase to 80. Then also both are same, sir. Increase to 90. Then also both are same. Then these both are same. Then don't go with the C. For now CMO is going to approve the contract for whom? I mean renew the contract only for A and B. He will not approve the C. Like this. Is the points are clear? Everyone? Yes or no? If it is not clear, please ask. What are the questions you are having? If you are confused also, please ask. Whoever the students are confused or whoever the students are having the questions, please ask. With this, 3 tests are completed. 1 sample Z test, 1 sample T test, and ANOVA test. Now we are moving on to the next one. Yes, I'm going to provide for you some questions for your practice. 100% I will provide. Okay. Now, so here I'm going to upload. Once the class is completed, I'm going to upload this one. Just I'll show you the sample questions so that you'll understand what you have to do. Immediately after the class, I'll upload them. Also, I will upload one test book. Already I have uploaded the test books in your drive. No. So I'm going to share you the test books. This folder will be added. In this folder, you can find in terms of 1 minute, not this folder. So in the Google Drive textbooks. So this one I'm going to share it to you, and this is the textbook. Okay, statistics related book for your reference purpose. So in this book, guys, please tell me whether we have completed these things or not. You only have to tell me what is statistics, what we are going to understand from the statistics, exploring the data and data mining, and what is probability. Next, what are the types of variables? Univariate data. What is univariate data? Single column. What is bivariate data? Multiple columns. What is univariate data? More than two columns. Next, discrete and continuous. What is discrete quantitative data is called as discrete count and continuous. And similarly, ordinal, nominal. Time series data, cross-sectional data. Did I explain all types of data? Next, histograms. What is the difference between the histograms and bar charts? Bar charts are applied on the discrete variable. Histogram is applied on the continuous variable. Normal distribution and skewed distribution. Next, outliers. Did I explain the outliers? Next, coming to the average, median, mode, percentile, quartiles, box plot, cumulative distribution. Cumulative distribution means cumulative frequency or cumulative probability. Both comes under cumulative distribution. And I have explained for you the after chapter 4, chapter 5. That is, here we have discussed what is deviation and what is variance. What is standard deviation? And how for standard deviation for a normal distribution. Standard deviation for a normal distribution. Center you have to write the mu. After that right side you have to write mu plus 1 sigma only. Okay, like that. Next, range. Next, I have explained for you coefficient of variance. Next, in the 6 probabilities. What is calculation for the probability of the discrete variable? How to calculate the probability of continuous variable? Next, 7. Normal distribution, standard normal distribution. What is standard normal distribution? Converting every value to corresponding z-score. In the bottom, what you will have? Mu is equal to 0. Sigma will be always 1. Just open your notes. Okay. And next, from here, we have move on to the next concept, inferential statistics. Now, if you open this one, almost many things will be completed. Majorly, you have to focus in the 10th chapter. Here, different questions are there. So for your inferential statistics, if you want to prepare, here you can prepare. Okay, some questions. Almost this textbook was completed for you. Mostly. Okay, just if you want, you can go through the reference. As of now, if I'm saying something to you like that, after the class, you only can open now. You only can see, right? Right? Now, this textbook I'll add for you for your reference. And along with this, I'll also share you the task. Coming to the task, I'm going to share you the inferential statistics related questions. So these are the questions which I'm going to share it to you and you have to work. Okay. All these are manually only. Okay. None of them is Python, and wherever the Python code is required, there will share you the data set also. In the bracket, it will be clearly mentioned. Please use the data set, this one. Then you have to use that data set. Right. So these are the things which you have to complete by tomorrow. Okay. Maximum number of questions. Okay. I'm going to upload after the class. And once you have completed, I'll share you the solutions also. Okay. Once you complete your things, I'll share you the solutions. Done? Everyone? Now coming back. Now coming to this one proportion test. So now balance 2 tests are only left. What are the 2 tests? One is called as one proportion test. Second one is called as chi-square test. These 2 will try to complete on the Monday. Along with these 2, we'll discuss the type 1 error and type 2 error. Still, inferential statistics is not completed. So Monday, we are going to cover 3. Remember this. Monday's class. Monday, we are going to cover, okay, statistical tests. Statistical tests for discrete variable, for discrete. That is nothing but one proportion test along with the chi-square test, and this will be completed just in 20 minutes. First 20 minutes it will be completed. From there I will tell you what is type 1 error and type 2 error. There is a concept called as type 1 error and type 2 error. Means sometimes the null hypothesis will be correct. Actually we have to accept, but sometimes we have to reject. How this is possible? That one only called as type 1 error and type 2 error, which we are going to see on the Monday. Okay. Sometimes we'll do the wrong prediction also, which we call it as error. Okay. Now, for example, there is a person. Person is innocent. Basically, he has not done any crime. He is an innocent person. But judge has told that you are a criminal and he has put in the jail for 10 years. Is that possible or not possible? Possible, na? At least one case will be there, na? Okay. What are the cases are there? They are called as errors. Why the judge will do like that? Means evidences are like that. What judge can do? Evidence is like that. What judge can do? Though he is innocent also, but all the evidences says that he is a criminal. Then what judge has to do? He can't say that though evidences are there, these are all the false evidences only. You are a genuine person. I know about you. I will leave you. He will not say like this, right? So based on the evidences only. Similarly, based on the data, we have to reject. Is the point is clear? So here the important point is sample. How we are going to select the sample, that called as sampling techniques. So we are going to learn here sampling techniques. On the Monday, I will explain you the what is the reason behind the type 1 and type 2 error. Means you are citing a wrong sample. When you choose in a wrong sample, automatically from that analysis also will be done wrong. Final conclusion also will be wrong. Sampling techniques. What are the different sampling techniques are there that we are going to discuss on the Monday. Sampling techniques along with this, and also third one is next one. Okay. The fourth topic which we are going to discuss is how to convert a skewed data to normal data. So these are the topics which we are going to complete on Monday. With that, statistics will be completed. Inferential statistics will be completed, guys. Okay. Now, tomorrow there is no test for you. Try to complete the task. I'm going to share you this task now. Try to complete the task. What are the tasks? I'm going to share it to you immediately after the class. Try to complete all the questions by tomorrow. Maximum number of questions. Okay. Monday we'll complete this one, balance part. After completing on Monday, Tuesday we'll have the test. Conducting the test is not important. Test has to be conducted on the overall syllabus of the statistics. Again, part of the things missed means these questions when I have to test you again. So first let us complete the statistics. Later we'll do the testing. So now you are having the time for preparation also, time for doing the practice, complete the descriptive statistics task, inferential statistics task. Monday we'll complete the statistics. Tuesday at 4 o'clock we'll have the test. Once your statistics is completed, we'll have the statistics based test. Is the point is clear, everyone? Done. So tomorrow there is no test for you. Test will be on the Tuesday. Tomorrow there is no class. Tomorrow there is no test. Only tomorrow is preparation. You are going to complete the descriptive statistics task, inferential statistics task. All the tasks you are going to complete. And this is your marks for your last test. What are the tests you have conducted recently? This is your marks for both online and offline students. This is offline students marks. This is online students marks. Whoever has attempted the test, you can check your marks and you can leave. And test solutions of your test, what are the solutions are there, it will be uploaded in the drive. You can cross check yourself. Statistics based MCQ test was conducted, right? For that marks. Others, you can leave. If no questions, you can leave. Sorry. Notes and everything will be uploaded just in 2 minutes. Wait, hold on. Now itself I'll upload. Notes will be uploaded now only. Just give me 2 minutes of time, guys. Notes and task, everything will be uploaded now only. Just give me 2 minutes. Yes. Included. Yes. Just cross check once. Yeah, online students, just please check your notes was uploaded. Just please confirm for me whether you have received your notes or not. Just check your drive once. One minute, one more minute. Sorry, my mistake. 1 minute. Just hold on. Hmm. Yeah, could you check now? Notes was uploaded. Yeah, Namrata, have you shared your solutions to the given mail ID? Namrata Naik. Yes. And have you shared along with your name and batch details? In the mail, have you shared your batch details? Only name. Then it is difficult, right? So along with the name, you have to add the batch. Otherwise, you will be considered in the another batch, and those answers will be considered for you. Yeah, I can understand. But when you are sending a mail, please forward in terms of along with your name and batch details also, because your questions are different and other batch students questions are different, right? Done. Yeah, sure. Sapna, I'm going to upload the book. I'll upload the task, everything. Okay. In another few minutes, everything will be uploaded. Right? Sapna? Done. Thank you.